So I found the load for the equal angle with size 80, which are located between 10 to 20 meters. It will be 5.2 kilograms per meter, and I will add it to the scheme. So I will select all the angles in this height and will add the load on bars. Press on. Sorry. Oh. Okay, so we have finished loading the angle 80, and now we start loading equal angle with size 75 millimeters. We will start from the first still up to 5 meters. If there are some one in our scheme, 75 fragmentation. Yes, okay, what about this node height 4.5? So I will choose two horizontal bracing elements. They're just in the height 4.5 meter. 4.5 please. And I will add to them the first load. What about next ones? It is 10 meter, 10.5. This 14.5. From 5 to 10 and from 10 to 20. So I will make copy on this height from 10 to 20. I will select two of them, load on the bars, use it, and we'll select it. I will check the height of these two elements. $60, 21 meters. Okay, so I need to add on this horizontal bracing the same load like the previous one. And the last will be loaded by the loading for 820, between 20 and 30. Okay. Restore model, that's all. So did we add it to these elements? I need to know. Yes, we added. Okay. So I think we added to all of the contractions. So it means that we finished adding this ice load we finished adding the snow load, payload, and the own weight. And now we have to add the main load, that is wind load. Wind load is added like the previous one, but it will be more difficult because we need to use not the direction of loading like it was in ice loading. It will be X direction and Y direction. So one of them will be perpendicular direction to the tower, to the tower, and the second one in diagonal direction tower. So, and we should prepare these two tables. So that's why it will took some more time, because one lesson we spent for adding only ice load, and here is twice more work, and I think we will not finish in this lesson adding the snow load. And maybe if I will show you the principle, maybe you will finish it by yourself, maybe. So what we know about wind load? The total load of wind is finding according to this formula. There are normative load from the wind pressure. We took it from the table where you are given the region of wind, and according to that region you should accept the load from the wind. Then coefficient according to change the pressure on the height, so that is accepted according to the region of location of your building. You also, according to the task, have the location A, B, and C. So A, it is open places, where you can read this information here. So open places nearby water lines, lakes, and so on. The location number B, it's a city territory, but there can be located some forests and buildings with a height not more than 10 meters. And the region C. The region C is buildings located in central part of the city with a height more than 25 meters. So, okay, what about my variant? My variant is A, and zero region according to wind pressure. So what about zero? My wind pressure will be 17 kilograms per square meter, or 0.17 kilopascals per square meter. And coefficient A according to the type of location place. So I will took these coefficients when I will use the formula. Here we see the additional coefficients K1. So it is according to the direction of the wind, so perpendicular to the tower and in the diagonal of the tower. So there are three various types. When there are triangular shaped tower, squared, and also squared, but in opposite direction, in diagonal direction of wind. So our wind according to the perpendicular surface of our tower calculated due to this table. So here is the height of elements, This is the coefficients which took according to the location place. So in my case it is A, and I took the 8 variant. In this column I will write 17 kilograms. You will write your own positions according to the task. The safety coefficient of wind will be the same, 1.4. There are no reason to change it. The coefficient Cx will be also the equal 0.95. Coefficient K1, which accepted according to the changing direction of wind, also will be the same. And the aerodynamic coefficient also will be the same. So you change in this table only this position, the second table column, and the third column. This variance you took from your task. And after then you need to multiply positions, multiply all of them or not. Now I will look more correctly. We use this coefficient and defining aerodynamic coefficient. So now I will check. 1 minute. Okay, so we multiply 4 positions. The position from the column number 2, column number 3, column number 4, and the column number 6. We don't use these 2 positions because they was used previously when there was find the aerodynamic coefficient. Only these 4 positions we multiply between each other. Now we will use again the help of the additional program, Excel, MS Excel. We'll put this table to this program. We'll delete these 2 meanings of 2 columns and also delete the answers. And now I will create the formula. We'll write this position is multiplied to this position, this, and this. So we had already defined, and we'll put again in this table. So the same thing we make for the diagonal direction of wind. This was perpendicular direction, and this is diagonal. And again, I change the third column according to my own task. I will make the copy of this table. We'll put to the Excel. Okay, I need just only the first one. So I will delete 2 of these columns. Delete the total load. And we'll again create the formula where we'll multiply needable parameters between each other. Okay, make the copy and we'll put here. Okay, that's all. Now I will use this finding total load and will put it and I will put it here. The load for 1 square meter. According to the height 5, 10, 20, 40. Here is perpendicular position, so I will take from this table. So from 0 to 5 according to the height, 0 to 5 meter. Put here. Next, from 5 to 10 meter. Next position from 10 to 20. I'm sorry, not this position. Put it in this column. And the last one from 20 to 40 or to 30 meters in our case. That's all. Now we'll find the we'll put the load for 1 square meter to the diagonal direction, and now we use this table. We'll copy and we'll put. Okay, next. Next will be from 10 to 20 meters. As you see, it really took some time to find it, but it will take more time when we will add it to the construction. So, in my opinion, the most difficult it is to add the wind load to the tower constructions in general, not especially for our tower, for any shape, for any section, for various height towers. It's most difficult to add the wind load. Okay, so again we'll use the help of the Excel. We'll delete the radio loads, total load, and again we'll add the formula. Section we multiply to the load. make the copy. That wasn't right. I'm sorry. It's not right. Because first of all,
Sorry,
to change the section size.
sorry, Alexander Alexandrovich.
Yes.
How you paste on Excel these executions? Yes.
Just make the copy of this table. I make Control S buttons, press the Control S button. That's all. You
just I do this process, but I don't. Я не смогу сделать, короче, это.
Это делается очень-очень просто. Вы копируете таблицу, нажимаете Ctrl-S, открываете Excel, нажимаете левой кнопкой мыши вот так на активное окошечко.
Да, там у меня просто в конце нет. В конце у меня, короче, выходит какое-то это значение. Я уже на шестое видео сделал уже.
Вам нужно вместо запятой поставить точку. Формула работает только, когда вот здесь есть точка.
Все. Ага, понял. Спасибо.
Она в другом случае не работает. Тогда у вас будет вот типа значение какое-то неправильное.
Да, просто я вот эти вручную все делал в итоге. Спасибо.
Не надо вручную делать. Я поэтому только Excel вам предлагаю использовать. Okay, continue. So we need to change the section. We need to change section, and only after then we'll find the total load. 75. Here we have 100 millimeters. In this case, I have 90. And 75. $75. $90. $100. $121. Here is 114, if I'm not mistaken. 114. I think that's all right. That's all right. I will make the copy of these two positions and will paste it to my table. Now I will delete this. In this table the answers, and I will add the formula where I will multiply this position to this position. Press enter. Now I will make a copy of this column and will paste it to this table. This table in the last column. Okay, that's all. So I will delete not needable elements. Then I will make the same copy for the next table. I will put it here. I will delete it. Then I will delete this position, and I will copy this table and put it. Now I will multiply the section size to the load, and we'll find for all positions. Now I will make copy of this column and put it into this table. Okay, cool. We finished. We did it. Very nice. Now we can start add it to the tower. So we will use just these two tables and the last column. For the first of all, for the pipes at various heights, and then to the angles also in various heights. So I make the copy of this load and go to the pipe 133 in diameter. First of all, I need to create additional load. It will be a wind load. According to in X direction. In X direction. Short term. Okay. And I will make the copy. Okay, we'll create the same. First of all, set as current will be X, wind load at X direction. I go to polyfilter using the stiffnesses, and first I will use pipe 100 fragmentation 33 up to 5 meter, 6 meter, 0.5. Okay, 0.5 will be enough for us. 0.5. I go back to the explanatory node. I copy the load for this pipe. I go to bars. I will use direction X, uniformly distributed load, and we'll write this number. Now I see from the direction X the load to these elements. Then I need to choose the height from 5 to 10 meters. Go to back, make the copy of this load, and we'll add it to these elements. Direction X, don't forget it, to change direction. Put it. Press OK. And the last elements. Last elements. Load and bars. Direction X. Put here. Press OK. So we finish the first position. Restore model. Then we need to use polyfilter again. We select the next pipe, make the fragmentation, see the height of them, 21, so from 10 to 20 meters. Select it, use 21 from 10 to 20 meters. Make the copy, load, bars, direction X, and paste. Okay, and restore model. And the last one part, rotation, for 20 to 30 in the height. Direction X, press OK. Restore model. That's all. So we loaded our pipe, our main legs or main vertical and inclined columns. So how you will say it also will be right. Now we start from the loading our angles, equal angles, and we will start from the angle on the height to 5 meters with size 100. We need to use filter by stiffnesses 100, orientation, and I will select first part, load, and bars, direction X, and so on. So did you understand the principle of loading with wind load? Or not? Maybe I need to repeat it in Russian, for example, or not? What do you say, students?
Can you repeat in Russian?
Please repeat your answer again. Okay, I will think that it's not so difficult because you will have a ready video, and if you will look at it, I think you can repeat it.
Okay.
9 meter and 10 meter. I will close it. From okay 10, so there are no answer for 10 from 5 to 10 meter. Why so? So I will add the line. I will make the copy. I will copy this position from 5 to 10 meters. And I will multiply this position to the size 0.029, 30, 26 multiplied 0. And again, we add this load according to the direction X. Restore model, save the model. So we have less than 2 minutes. If you will have some questions, or maybe you want that some information will be repeated, so I will do it. And actually, we will
Do we
connect
have any
our
questions?
lesson on the next hour, next time, so maybe on next week. So, what do you think?
Yes, I agree.
Okay. Okay, so if there are no questions, I will be stop our video, right?
А уголки, которые дальше